Today we're going to look at how to simulate probability. So, not right now, but in a little while, you're going to need your iPad. Don't worry about getting it out right now. You don't need it right this second. But we are going to use a random number generator. Like I use sometimes, you may have noticed every now and then I'll be like, I'm not getting enough volunteers. I'll use the random number generator in my calculator to tell me who to pick next.
I don't like that thing.
Okay. But you can use one as well to simulate probability. So, a lot of times when you're simulating something, you use random numbers. We do this actually in my AP statistics class as well. So random numbers, at least in theory, have no pattern. They cannot be predicted in any way. Knowing a random number in no way allows you to predict what the next random number would be. An example of a random number generator is just a standard number cube, which is usually generates numbers from 1 to 6 when you roll it, right? They also make other size, right? For anyone who's ever played a role-playing game, they make, 4-sided, 6-sided, 10-sided, 20-sided. There's all these different number of sides. I think is there an 8 also? I can't remember.
I know there's a 20.
Right. Do you know what the name of a 20-sided die is called?
20-sided die.
It's an icosahedron.
I can't say that word.
Yes, you can.
I know 12-sided.
Pardon?
I know 12-sided.
You know 12?
Yeah.
What is that? Pardon? Yeah, it's a dodecahedron. Do meaning 2, deca meaning 10, like a decade is 10 years. All right, anyway, so we're going to start without the random number generator. Imagine that a random number generator that produces numbers from 1 to 20. In each game below, if the stated outcome happens, player X wins. If not, player Y wins. So, game 1, if it pulls a prime number, or if it generates a prime number, player X wins. Prime numbers have exactly 2 factors, 1 and itself. So let's list all of the prime numbers between 1 and 20. So what would prime numbers be between 1 and 20? 2?
3, 5, 7, 11, 13,
Yep.
17,
And
19.
19.
Numbers.
Those are all the prime numbers. Occasionally a student will ask, is 1 a prime number? And the answer is no. Because of the way this is defined, it says it has 2 factors.
1 and it.
Right, so it has to be 1 and itself. It can't be 1 twice. All right, so even numbers, this should be a little easier. What are the even numbers between 2 and 20?
2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
Exactly. And then let's do numbers that are not divisible by 3.
2.
How about 1? Is 1 divisible by 3? So 1, 2, 4, 5, 7, 8, 10, 11.
13,
Yep.
14, 16, 17, 19, 20.
Yep. All right, so let's find the theoretical probability that player X wins. Remember, the theoretical probability is given by giving a fraction, where the top number is how many desired outcomes there are, And the bottom number is how many total outcomes there are. So for game 1, the probability that player X wins is going to be equal to, well, how many ways can player X win? 1, 2, 3, 4, 5, 6, 7, 8. It's 8 out of 20, which we can reduce to. We always want to reduce these. 2 over 5, exactly right. So, do we have to count all of the other ones to know the probability that Y wins? No. What would be a fast and easy way to find the probability that Y wins?
20 minus 8.
Well, 20 minus 8 is 12, and that's not a probability.
5 minus 2 fifths. 20.
What minus 2/5? Well, you could do 5/5 minus 2/5, because what is 5/5? 1. The probability that X will win plus the probability that Y will win has to be 1. One or the other one is going to win, right? So the probability that Y wins is just 1 minus 2/5, which is 3/5. All right, now let's do game 2. What's the probability that X wins?
1/2.
Because,
It's 10 out of 20.
yeah, there are 10 numbers out of 20. I always start with the raw numbers and then reduce it, so that's 1/2. So what's the probability that Y wins?
1/2.
It's also 1/2, because it's 1 minus 1/2, which is 1/2. And then game 3, probability that X wins. Oh, there's a lot of those, aren't there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 20, which is 7/10. The probability that Y wins is going to be what then? 3/10. Because that's 1 minus 7/10. In which of the 3 games is player X most likely to win? Game 3. Why? Because 7/10 is greater than 1/2, which is greater than 2/5. All right, so let's say you play the prime number game 40 times. How many times would you expect player X to win? Well, we're going to take the probability, 2/5, and multiply it times 40, which I'll write as 40 over 1. You can multiply first and then divide, or you can divide first and then multiply. Hint, it's always easier to divide first. 5 goes into 40 8 times. You would expect to win 16 times. For 50 times, we would take 2/5 times 50 over 1. 5 goes into 50 10 times. You would expect player X to win 20 times. All right, That's the theoretical probability. Well, what we're going to do now is you're all going to, in just a moment, use a random number generator to play the game 40 times and see, does it really come out to be 16? Now, would we expect it to come out to be 16 every time? Probably not. But we're going to do something with that. So, let me show you what it looks like. Let's see if I can find where I put it. Where did I put it? There it is. All right. In just a moment, when you get out your iPad, what you're going to do is do a Google search for random number generator, and this is what's going to come up. Everybody do that. Let's make sure everybody can find that. Okay. Yeah, you can just watch with somebody. That's fine. Actually, you know what? I have mine with me today. Oh, but it's not hooked up to the network. Never mind. Anyone having difficulty finding this random number generator? All right. And what we want to do is set the minimum number to 1. I think it's already set that way. But we want the maximum number to be 20. I think that it comes with 1 and 10, right? When it first loads. Yeah. Okay. So what I want everybody to do is we're going to do an experiment. I want you to play the game 40 times. Now you're going to have to figure out a way to keep track of how many games you played. I want you to play exactly 40, no more, no less. And I want you to play game 1, which is the prime number game, and I want you to keep track of how many times player X wins also. So you need to keep track of 2 things, how many games you played and how many games player X has won, exactly.
Wait, so we do each of the 3 games?
No,
Do
just
40
game,
times?
just game 1.
40 times.
Just game 1, 40 times.
Is it just one rule for a game?
You're gonna play the game 40 times. So you're gonna generate a number, see who wins. That's once. Then you do game 1 again. You just put a number, see who wins. All right, here, let me show you. All right, so I'm gonna generate a number. Is 6 a prime number? No. So I've played once and I have 0 wins. I'm gonna do it again. I've played twice and I still have 0 wins. I'm just gonna keep track until I get to 40. Okay? So let's see. It's 4, 1, 5, 1, 6, 2, 7, 3, 8, 4, 9, 4, 10, 4, 11, 4, just came out really close.
Oh, you got 15.
How many I
I
got?
got 14.
Bro, I got 11.
I got 23.
I got 19.
I got 19.
I got 11, bro.
I was one off.
Wait, how do I write it? I never know. How do I write it?
Oh, you right, like.
All right. If you have, if you're done with yours, if you'll raise your hand, I'm going to write down what everyone got.
11.
11.
14.
Coop, what'd you get?
15.
15? Yeah. Ben? 7. Sophia?
No, 17.
Oh, 17. 11. How many?
I got one once and messed it up, so 20.
20? That's a lot. Barrett?
16.
Yeah. 23.
Yeah.
Johnny?
19.
19. Christian, did I get yours?
Yeah.
Okay. Oh, I didn't put mine up here. I only had 9. And so I kept rolling 1 over and over and over again.
You're gonna average
I
it?
got one once.
I am going to average it.
I got 15 straight.
I'm going to wait for our last 2 and then we're going to. So for mine at least, his experimental probability is 9/40ths, which isn't particularly close to what his theoretical probability is. Let's see what we've got so far.
I got it too.
Wait, what'd y'all do?
You type in like a big number, there's like this weird space.
Yes, ma'am. You got 20? Not 22, but 20 also?
Join me, Natalie.
Put the max as 1 3.
Bella, you have yours?
Yeah, I also got 20.
You also got 20? Okay. All right, if we take the average of these, it's going to be 195 divided by 369, 12. Pardon? I didn't count you, I counted me. Okay, so this is one of the big ideas in statistics, is that if you have a theoretical probability and you do an experiment just a few times, you can be way off from the experimental probability, right? But now we have done this almost 500 times between the 12 of us, right? 12 times 40 is 480. So we've played the game almost 500 times and we're getting really close to the expected value. If we played it 4,000 times, we would probably be extremely close to our expected value. That's one of the ideas of statistics. All right, let's go on to the next page. If you will, please put your iPads away so that they don't, or just you can leave them on your desk, but just shut them so that they're, not calling to you. So Sophia and her brother are trying to create a fair game in which you roll 2 number cubes. Ladies, they cannot agree on the probability that the numbers on both number cubes will be even, so they decide to design a simulation. So what do you think the probability is going to be that both of the dice are going to be even. Don't say anything out loud. What do you think the probability is going to be that the first one is even and the second one is even, both? Write down a fraction that you think is correct. It's okay if you're wrong. Don't worry about it. I'm not going to out anybody or make fun of anyone. Make a guess. But everybody make a guess. Don't figure it out. Don't think about it very long. First reaction, what do you think it's going to be? All right. So now we're going to design a simulation with a random number generator. How many random numbers do you need? And in what intervals should they be? So we need 2 random numbers. Bless you. And they need to be what? Between 1 and 6. All right. So this time we're only going to do it 25 times because this takes a little bit longer because you're having to generate 2 different numbers. So let me show you what it's going to look like. So I'm going to go from 1 to 6. And I'm going to go generate, generate. Were they both even? No. So what I would do is keep track of how many no's you have and how many yeses, and maybe even while you're doing it, like for me, yes, no, I have 1 no, and I might do them by, you guys know how to do tick marks by 5? 1, 2, 3, 4, 5. That makes it easy to keep track of it rather than having to count them all. Everybody try this 25 times.
Wait, can we put it in the
Pardon? Yeah, do it on.
chart?
Yeah, you can keep track of it here. You don't have to make your own. So go ahead and use your iPad to do that.
Wait, we have to generate it twice.
So you do 2 numbers. If they're both even, it goes in the both even column. If they're not both even, but you always have to do 2 numbers. Don't do 1 number and say, oh, that's not even, I don't need to keep going. Always do 2.
That one right there.
So if it's not too even, then it's no.
Correct.
That's 6 and up.
Well, we've gotten 2 odds, but not 2 evens.
I'm sorry?
I'm sad.
Why are you sad? Why are you sad? You didn't have any wins? That seems very, very, very unlikely.
Yeah, neither did I. He didn't have any wins either.
You never had one where there were two even numbers in a row?
Oh, wait.
I don't know how. I only won 3. I mean, I can see why, because I only got 3 wins.
Bro, I have 6 yeses.
Dang.
That's 0.
Bro, I can see
Same,
why
how
you
many
won.
else you got? 6?
No, I still have 5 more. Bro,
Bro, I can see how you would get 0, because I only got 3.
I got 0.
Dang.
I got 0.
4.
Man, I thought it would
And
be a
six.
50-50%
Oh, no,
maybe.
no.
I want my jacket back.
Nice.
Yeah,
Bro, that's
I
not
want
close to
that.
50%.
I know.
Bro, I got one of those. I want that. That one's my mom's. She yelled at me.
Okay, last one. Will I get another
Is
yes?
it me? But you said yesterday.
I got 7 yeses.
You
And
got
18 no's.
All right.
I got 6 yeses.
So, I already know that there's a couple of you who said you got 0, which is boggles the mind, but that's okay. How many of you got 1? Just by a show of hands. I'm not going to keep track this time. How many of you got 2? 3? 4?
Dude, how do people get more than 3?
5? I got 5. 6? 7? Anyone get more than 7? How many did you get? 8? 13?
Nah.
Yoink, Scoob. Okay,
13 is almost half.
so
That's like double.
for my experiment, the probability of them both being even for mine was 5 out of 25, which is 1/5. Now, I will just tell you, actually, I'll go ahead and show you how to do it. What's the probability of getting an even number the first time?
12.5.
Okay, the probability is always, probability is always a fraction or a decimal or a percent that's smaller than 1. So what's the probability that I got an even number out of 6? Well, how many even numbers are there? 3 out of, which is
No, I have
1 half. So don't need to write this down. I'm just going to show this to you. What's the probability that I get an even number the second time? 1/2. The probability that I get an even number and another even number, you actually just multiply them together. It's 1/4. Our expected value on this is actually just a little bit more than 6. So for those of you who got 6, yeah, whatever you're paying attention to that's not in class, stop paying attention to it. Okay? So there were a couple of you that got 6. Yours was closest to the expected value. Right? If you got 13, well, you're helping to balance out some of the ones who got 0. Okay? All right. So, let's look at this one. And like I said, we'll learn how to do this later on, but I just wanted to show you that it's actually pretty easy on one like that. One like this next one, way more difficult. A gentleman who used to work here and I spent 30 minutes figuring out how to do and I really mean we spent 30 minutes trying to figure out the theoretical probability for this one. It took a while. So, Janelle is going to babysit her nephew all day 5 times this summer. She had the idea that one way to entertain him is to walk to McBurger's for a kids' meal for lunch each time. The kids' meal comes with packed randomly with one of 3 possible action figures. Janelle would like to know the probability they get all 3 action figures in 5 trips. So we're going to call the action figures action figure 1, 2, and 3. On this one, I'm going to do the random number generator just because it'll be faster, because I can do it on a calculator where it'll generate 3 random numbers at a time. Okay? So, let's take a look. Let me open this up. Bounce, bounce, bounce. Open, open, open. All right, clear that stuff out. In the math menu, there is a probability menu, and you can generate a random integer. Now, how many different toys are there? There's 3. So I'm going to call them toy 1, toy 2, and toy 3. So I'm going to do from 1 to 3. And how many times are they going to go? They're going to go 5 times. So what this is going to do is it's going to pick a number between 1 and 3, and it's going to do it 5 times. And we're going to see, did they get all 3 toys? Does that make sense? So like on this one, did they get all 3 toys? Yes. If someone will just keep track of how many times we got all 3, and actually everybody keep track of it. I'm going to try to do this 50 times. Stop me when I get to 50. Actually, I'll keep track of that. All right, so first one was a win. We got all 3. You don't need to do anything don't do anything on your iPad. Just, you got all 3. The second time we got all 3 again. So we've done it twice now. We've got all 3 both times. The next time, yep. That's 3 wins in a row. Next time, yep. Oh. So now we've done it 5 times, and you should have 4 of all 3 and 1 of not 3. Everybody good with that? All right, let's go a little bit faster. Yes. Yes. No. Yes. Yes. Check me. Is that 10 so far?
Yes.
What is it? 8 yeses and 2 nos? All right. So the next one is a yes. The next one's a yes. The next one is a yes. The next one is a no. Next one's a yes. 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 No. Yes. We should be up to 20 now.
Yep.
Thank you for keeping track. No. No. It's the first time we've had 2 no's in a row. No. 3 in a row. Wow. Yes. 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 No. Yes. 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 Double check me. I got 30 at this point. All right. How many yeses do we have, just real quick? 22 out of 30. If I do that as a decimal, it's 0.73 repeating. Shh, quiet please. So what actually happens on this, sit down. Okay. The actual probability is 0.62. So we're pretty close after only 30. Y'all have a great day. Your assignment is in the book. Oh, yes.